Hi there, this video is going to be about Lewis electron dot structures and covalent compounds. We already did a video on ionic compounds, so this is going to show how it works with covalent compounds. And some of the same rules apply here. For example, with the octet rule, that's the tendency of an atom to obtain an electron configuration with 8 valence electrons, 2 in the s and 6 in the p. And the only one that doesn't need to do this is hydrogen. Hydrogen just needs 2 electrons for a complete valence shell. That's just filling up that 1s orbital. And so for this, what's different here with covalent compounds versus ionic compounds is with ionic compounds, you're transferring electrons, moving electrons from one atom to another. Covalent, they're sharing electrons. Let's talk about hydrogen here first of all for this particular system. And hydrogen atoms, again, have just one valence electron. Once again, you can look at the periodic table. Here's our periodic table, and again the column number tells you how many valence electrons there are for that particular element. So for example, hydrogen in column 1 just has one valence electron, so we show that with a single dot there. And of course that doesn't satisfy the outermost energy shell for hydrogen, and so instead what hydrogen does is it actually reacts with itself. And so if we bring in another hydrogen atom, neither one wants to give up an electron here. So what ends up happening is they share the electrons. That's what covalent means for this. So this hydrogen puts in an electron, that hydrogen puts in an electron, and the result then is what we call a single bond, a hydrogen-hydrogen bond. We show the 2 electrons just with this single line between the 2 hydrogen atoms. Chlorine does something very similar to this. Chlorine's going to have 7 valence electrons. Again, we show those 7 electrons as dots around the atom there, and so there's our 7th electron. And chlorine kind of does the same thing hydrogen does. It only has 7 valence electrons, so when there's a bunch of chlorine atoms, what they end up doing is combining with each other. Each one puts in an electron to be shared with the other. And so again, how we show that, we'll put in those unbonding or non-bonding electrons around the chlorine atoms there. So we have 2 that are bonding, again that's what the line represents, and then the other 6 around each chlorine. So each chlorine, even though there's only 14 total electrons, each chlorine atom has its octet. Again, there's 2 in the line here, so 1, 2, and then 3, 4, 5, 6, 7, 8 electrons around this chlorine, and 1, 2, 3, 4, 5, 6, 7, 8 around that chlorine. So that's how chlorine can satisfy the octet rule when it's just individual chlorine atoms in that case. Oxygen can do something similar. Here's an oxygen atom. Oxygen's only going to have 6 valence electrons. Here is chlorine with 7. Oxygen's in this column. They all have 6 valence electrons for that. And so if we put those atom or electrons in, 1, 2, 3, 4, 5, 6 there, it does very much the same thing. I'll fill in the electrons with that. And so here, just putting 1 electron in each, though, doesn't do the trick. That only gives you 7 valence electrons around each atom here. So 1, 2, 3, 4, 5, and then there's 2 shared here. That's 6 and 7, and the same thing there. So no octet rule just yet. So instead, each atom puts in a 2nd electron to be shared. We put 2 bonds between them, so that's 4 electrons being shared. And there's our remaining electrons on each of the atoms there. And that's how we get 8 electrons. 1, 2, 3, 4, and then 5, 6, 7, 8. Again, in those shared electron pairs there. And the same thing on this side. And so we call that, oops, that's a double bond. All right, and these up here, we call those single bonds. Even nitrogen gets into the act, or can. It's only going to have 5 valence electrons, and so instead of sharing 2 pairs like oxygen, it's actually going to share 3 pairs of electrons between the 2 atoms. So these get shared, and this set gets shared. And so we end up with 3 bonds between the 2 nitrogens, and that forms a triple bond. All right, so that's how we can form single, double, and triple bonds for just some very simple covalent compounds.